This is Geometry, Unit 9, Day 2. We're going to write and graph equations of lines. From a previous lesson, we've talked about slope and how that's rise over run. There's a formula for slope, y2 minus y1 over x2 minus x1. We've also talked about how parallel lines will both have the same slope, and if they are perpendicular lines, they will have opposite reciprocals. Today we're going to talk about one way an equation can be written is in slope-intercept form. Linear equations in this form can be written as y equals mx plus b, where m is the slope and b is the y-intercept. The slope and y-intercept within that same problem, those are numbers that don't change, so we call those constants. The x and y within a problem will continually change. You look here at this particular graph, and the x and y are different at different points along the graph. But throughout the whole graph, the slope is the same, and the whole line has the same y-intercept. So that's why the y-intercept and slope are considered to be a constant. They stay the same throughout that problem. So we're going to write an equation of this line. Since it's written on a grid, we could do rise over run to figure out our slope. We're going down 3 and we're going over 5. So -3 for the rising and 5 for the run. The y-intercept is where the graph crosses the y-axis, and it crosses the y-axis up here at 3. So we're ready to write our equation in the form of y equals mx plus b. Your equation always has to have a y and an x. Our slope is -3/5, and our b value is a +3. We're going to write an equation of a line passing through the points 8, 12 and 6, -4. We're going to write this in slope-intercept form. So we're going to call 8 x1, y1, x2, y2. So label your points. When we calculate our slope, we're going to use the formula y2 minus y1 over x2 minus x1. Always remember to write your formula. Get used to how it's made. Recognize that we have minuses in that formula, and we also have the y's have to be on top. Rise over run. The rise is your y-axis, vertical direction, and the running is your x-axis, which is your horizontal directions. So y2 minus y1 over x2 minus x1 gives us a slope of 8. Now, if it's a slope of 8, we still don't know just where that graph is. It could have a slope of 8 at any point along a graph. The y-intercept is going to nail it down to being at a specific location. So the y-intercept, we're going to start out with y equals mx plus b. We can pick either one of our xy coordinates. Let's pick the 8 and the 12. So the y is 12. Your slope is 8. The x value is also 8. And the b value is what we don't know. So 8 squared is 64. Subtract the 64 over, and we get negative 52 for the b. So our equation is y equals our slope, which is 8 times x minus 52. This next one, we're going to write an equation of a line that passes through this point and is parallel to this line. So for example, if we sketch this out, we're going to have the point negative 6, 7. We also have the line already of negative 5 with a slope of 3. So we're trying to figure out the equation that is a line that goes through the point but is parallel to the line that they give us. There's a theorem that we've used before that says through a point not on the line, there's exactly one line parallel to that given line through that point. Only one line could be parallel to that through this point. The current slope of our given line is 3. When we want to write the equation of our line that's parallel to that, it has to have the same slope. And we're planning to make this go through point negative 6, 7. So we're going to start out with y equals mx plus b. Pick our x comma y. Our slope is 3, the y value is 7, the x value is negative 6. So we know the b value is 25. So to write our final equation, y equals, our slope we've decided is going to be the same as the original equation, so that's going to be 3. So we say 3x plus 25. We're going to write an equation that passes through this point and is perpendicular to a given line. So if we have a point that's at 4, negative 12, and we have an equation that crosses at negative 17 with a slope of negative 4 thirds, 4 divided by 3, it's negative, so it's falling to the right. We're trying to find the equation that's perpendicular. So that dashed line is the line that we're thinking about. We want to know the equation of that line. Our current slope is negative 4 thirds, but when we want to be perpendicular to that, we have to do what's called the opposite reciprocal. Opposite meaning that the sign's going to change. The current slope is negative, so our new slope is going to be positive. We also take the reciprocal. So instead of 4 thirds, we're going to say 3 fourths. We're looking for the point 4 comma negative 12. We want our equation to go through that point. So, as usual, we're going to start out with y equals mx plus b. Our y value is negative 12. Our slope is 3 fourths. X is 4. Plus our unknown, which is b. To calculate this, we can put it over 1. We could say 12 divided by 4, or we could just reduce the 4's off there. So we're left with negative 12 equals 3 plus b. Subtract that across to get the b by itself. So my final equation is y equals the slope, which is 3/4 x minus 15. Last one. We have this equation. It's written in standard form. That's where the x and the y are on the same side of the equation. Often if you write an equation through a story problem, you end up writing it in the standard format. So for us to write it in slope-intercept form, we want to get the y by itself. So we're going to subtract the 2x. And we're going to divide by negative 3. So notice that if you have a negative on top and on bottom, that becomes a positive. Again, if you have a negative on top and bottom, this one became a positive. 2 negatives makes a positive. So here's the equation. These two, they are the exact same equation, they just look different. This is in standard form with no fractions. This is in standard form in slope-intercept form. So we're going to come over to our graph. You always start at your y-intercept. So notice your scale goes by 2's. So we're going to count 4 on the y-axis. Then we're going to do the slope. So the slope here is 2/3. So 2/3. 2/3. Two-thirds, 2/3. So there's the graph of the line, and you always write the equation of your line on your graph.